Welcome to The Explainer. Today, we're diving into something pretty wild, the sneaky and honestly amazing ways your brain builds your reality. We're going to see how what you perceive isn't always what's actually there, and why that's not a bug, but an incredible feature of your mind.
All right, let's jump right in. Take a good look at this image. Looks like it's swirling all over the place, right? But now, try this. Focus your gaze on any single part of it. Just stare at one spot. See that? It stops moving. Now let your eyes wander again. And boom, the motion is back. So what you're seeing, or what you think you're seeing, is something called a peripheral drift illusion. It's all because your brain processes different levels of brightness and contrast at slightly different speeds. It's a tiny, tiny lag, but it's enough to trick your brain into seeing movement that just isn't there. And that's our first big clue that seeing is way more complicated than we think.
And here's the crucial thing to understand. Your brain isn't some perfect high-def camera just recording the world. Nope, it's an incredibly efficient prediction machine. It has to take shortcuts, make educated guesses, and fill in the gaps to build a reality that's useful, not necessarily one that's 100% accurate. That's why optical illusions are so cool. They aren't mistakes, they're like little windows into how that brilliant system actually works. They show us the clever tricks and shortcuts your brain uses every single millisecond. So let's explore how these so-called bugs are actually incredible features, starting with one of the brain's best tricks, filling in the gaps.
Okay, so first up, your brain fills the gaps. This is a huge idea. Your brain isn't just seeing what's physically there. It is actively creating what it expects to see, sometimes just inventing details to make the world make sense.
Take a look at this grid. As your eyes move around, you'll probably see these little black dots popping up and disappearing at the intersections of the white lines, right? Especially in your peripheral vision. Go ahead, try to count them. It's impossible. They just won't stay still.
And that's because there are 0 black dots, not a single one. This is called a scintillating grid illusion, and your brain is literally creating those little phantom dots. It's a side effect of how your retinal neurons process those high-contrast edges. It's filling in information that isn't actually there.
Your brain also creates motion out of thin air. It's a trick called the phi phenomenon, and it's the exact same principle that makes movies work. A movie is just a bunch of still photos shown really fast, but your brain connects the dots and creates the illusion of smooth motion between each frame. And it doesn't stop there. Your brain will even paint in colors that don't exist. With some illusions, just the color of a border can trick your brain into spreading a faint color across an entire empty shape. The color you're seeing is purely a creation of your mind.
So we know the brain invents details, but it gets deeper. It's also about how the stuff surrounding an object can completely change how you see that object. Your brain never sees anything in a vacuum. It's always making comparisons. Okay, here's a classic example. Which of the gray circles in the middle looks bigger to you? For almost everyone, the one on the right, the one surrounded by the little circles, seems obviously bigger than the one on the left.
But, you probably guessed it, they are identical, perfectly the same size. This is the Ebbinghaus illusion, and it works because your brain can't help itself. It uses the surrounding circles as context. Compared to big circles, the center one looks small. Compared to small circles, that exact same circle looks huge. Context is everything. And you see this principle everywhere. Perspective lines can trick us into thinking one line is longer than another. Or look at this pattern of bricks. That high contrast between the tiles tricks our brain into seeing perfectly straight, parallel lines as being slanted. It's all about how the brain interprets the information around the thing you're looking at.
So this brings up a really fascinating question. If our perception is so easily fooled, how on earth do we manage to, live in the world? How do we pick up a coffee cup or catch a ball if what we're seeing isn't the real size or location of things?
Well, that question leads us to something called the two-stream hypothesis. The theory is that our brain actually has two separate visual systems working at the same time. There's one stream for your conscious perception, what you think you see, and a whole other stream for guiding your physical actions.
Now, the original idea was pretty straightforward. A what stream to figure out what an object is, and a where stream to figure out where it is. But later on, researchers refined this. The newer model says it's less about where and more about how. So you have a perception stream to build your conscious picture of the world, and an action stream to guide how you actually interact with it.
And this is how scientists test it.
which is super cool. They'll show someone the Ebbinghaus illusion and ask which circle is bigger, and the person gets it wrong. But then they say, okay, now just reach out and grab the circle on the right. And get this, their hand isn't fooled. The gap between their thumb and finger opens to the actual size of the disc, not the size they perceive it to be. It's like your hand knows the truth that your conscious mind can't see.
Okay, but if that wasn't mind-bending enough, get this. These principles aren't just for your eyes. The brain's fundamental tricks, using context, filling in gaps, they apply across your other senses too.
Believe it or not, scientists have proved that the Ebbinghaus illusion, that thing with the circles, works through touch alone. They blindfolded people and had them feel 3D printed versions of the illusion. No visual information at all, just their sense of touch.
And the results are just stunning. When people just felt the two center discs by themselves, they could tell which was bigger about 78% of the time. Pretty good. But when those same discs were surrounded by the other contact circles, their accuracy plummeted to just 56%. Their sense of touch was fooled by the context, just like their vision was. Other famous illusions, like the one with the arrows making lines look longer or shorter, also work through touch. And they even work on people who have been blind since birth. That tells us that these shortcuts aren't just about how we process light. They are fundamental, hardwired rules for how the brain processes space and size, no matter where the information comes from. Which brings us right back to where we started. These illusions, these little reality benders, they don't mean your brain is broken. They reveal the incredibly elegant and efficient strategies it uses to build a useful reality for you every single moment, out of a chaotic flood of information. They aren't bugs, they're features.
And that leaves us with one final, pretty profound question to think about. If your brain is constantly filling in gaps, making assumptions, and building a version of reality just for you, what else about the world might you be misperceiving, or maybe even missing entirely?